So in this video, we're going to talk about the virtual machine file system, which is a key piece of understanding how storage really works from an operating system perspective when it comes to actually storing virtual machines. So we'll talk about virtual machine file system and how to work with it and some of the things that it's making available to us. We'll also talk about how we can more tightly integrate storage between our hosts and the actual storage that they provide, because we're going to be typically using some sort of network attached storage or some sort of storage area network with vSphere. We'll also talk about even deeper integration with the arrays beyond something we get with the vSphere APIs for array integration is also something called virtual volumes. So we'll talk about that. And we'll also talk about a handy utility for working with VMFS volumes and also VMDK files called vmkfstools. And then we'll take a look at the demo. So the VMware file system is file system optimized for VMDK storage. So there's a couple of different versions of this. There's effectively the older style version and then the more modern version, VMFS 3 versus VMFS 5. There's not very much we need to configure for VMFS. Effectively, we're going to format block devices, so local disks, fiber channel disks, iSCSI disks, but not NFS storage. We'll format it with the VMFS file system, and that'll break the file system down into 1 megabyte blocks with what they call 64K sub-block allocations. So for example, a VMX file, which is very small, doesn't need to take the minimum block size, which is 1 meg, but larger files such as the VMDKs themselves will be allocated in 1 megabyte blocks. And in the new VMFS 5 model, we've got 64 terabytes maximum per volume, and just slightly less than that for any one individual VMDK file. Although you'd get to a certain point, you'd have one VMDK on the whole volume. That's quite a lot. But the key piece here is that this is a cluster file system. So all the various hosts that I have in my environment, I'm going to get them to attach to these VMFS file system volumes, and they'll all be able to access the virtual machines running on them using file level locking. So this is a little different than, for example, something like a clustered disk in a Windows failover cluster, which is not actually designed to be accessed by multiple machines all at the same time, unless you're using something called cluster shared volumes, which is really for Hyper-V. So there's a couple of other capabilities that VMFS provides. Thin provisioning, which we've been talking about for our virtual machines, but also something called sparse provisioning, which can be used with, for example, VDI workloads, and are designed to initialize much faster, because this is one of the big problems in a virtual desktop infrastructure, is that when we try to start a whole lot of virtual machines all at the same time, that causes pretty heavy I/O loads, and especially if we're using like linked clones, then the normal process for doing that is a little faster using this so-called sparse provisioning mode. So this is typically something VMware View would do, but you can also do it by hand if it was necessary using vmkfstools. And then I suppose technically it's not really using VMFS, but if you present a LUN from your SAN or from your network attached storage directly to a virtual machine using raw device mapping, VMFS actually does do the mapping for that, so that the virtual machine doesn't need to have access to the SAN, for example, doesn't need to speak fiber channel, but can still be given access to a fiber channel LUN. And that could introduce some new disaster recovery scenarios, or some migration strategies and things that we might want to use for workloads that were already hosted on the SAN, but that we now want to bring into a virtual environment. So when it comes to working with VMFS volumes, it's really not overly complicated. Whenever we present new storage to ESXi, it's going to go out and scan that storage, and if it already has VMFS on it, then we just have to mount it and make it available as a data store. However, much like any file system, if that device does not already have a file system on it, we're going to need to format it, in this case using the VMFS file system. So this is not overly complicated to do, and we'll see it as part of the demo. If you're more interested in some of the details around how things like file system allocation and so on work inside VMFS, take a look at the links here. There's VMware KB article and also one from a VMware blog posting about new features in VMFS 5. So when it comes to doing storage allocation, we may get into a situation where the LUN that we were originally provided to us needs to grow because we need more space available to, the various VMDKs that are stored on that VMFS volume, or where we might even want to shrink the LUN, and then we've already got VMFS on it. So in the event that we want to make more space available to VMFS, we'll have to go to the storage and increase the size of the LUN that VMFS is on, or, the local RAID or something like that if we're capable of doing it. But anyway, make the disk itself bigger And then we can go in and expand VMFS to use that additional space. And this is very similar to basically extending any partition in pretty much any OS ever. On the other hand, if you want to shrink VMFS, well, there's a KB article that basically tells you you can't do that. So if you need to make the storage smaller, you're going to need to create a new volume somewhere else, a new LUN somewhere else, format it with VMFS, and then use, say, storage vMotion to move things to it. So you can, much like in other operating systems, I mean, the same fundamental concept of how disk layouts work still applies to ESXi. So you can partition those disks, and you could have multiple partitions on the disk, each formatted with VMFS. Your local storage is already partitioned to have the ESXi installation on, a Linux type file system, as opposed to VMFS, which is used for, that datastore one that gets created by default. But if you wanted to, you could have multiple VMFS on the same LUN, but there's really no reason to do this. You can also go and have multiple LUNs making up the same VMFS. So you can take one VMFS file system, and instead of extending it on the disk that it's currently on, you can extend it by adding another disk to it. So another local disk or another RAID volume or another LUN. Don't do this. There's really just about no reason to do this. There's very little benefit to doing it, and it's going to be that much more complicated to do it. And especially, if we have this on two different arrays or something like that, there's really very little reason to do it. People used to do this because you could have, potentially larger LUNs than you could do with VMFS and so on. Now, you should be able to create some pretty large LUNs and then some pretty large VMFSs on it. So I really would not mess with partitions and extents, but they're in the product if you feel like you need to use them. There's a lot of things that conceivably ESXi could do on its own. If I tell it to go create a thin provisioned file, that's relatively easy to do. If I tell it to go create a thick provisioned eager zeroed file of 500 gigs or, 50 terabytes or something, that's going to be potentially quite slow if my host has to go and write a whole bunch of zeros onto that storage. So what would be better is if we can just tell the storage what we want to do and then have the storage do it. And so this is what we call vSphere APIs for Array Integration, or VAAI. And there's lots of storage vendors out there who want to attach their storage to vSphere environments, so this is pretty widely supported actually. But the idea is that we can provide provisioning support and locking support and cloning and snapshot and migration and cleaning up dead space and all sorts of things by having the array do it without having the host needing to do all the actual, byte level operations that are going to go on the file system. And this is actually really good, for example, with thin provisioned disks. There are certain limits. When you're not using a VAAI capable storage, what will happen is that as you increase the number of thin provisioned virtual machines on that VMFS, and they start expanding, the file level locking that VMFS normally doesn't really apply. When we go to increase the size of the files, we actually need to start doing block level locking in order to make sure that we don't allocate the same block to two different files or whatever. This is much, much, much more detailed than locking a file, locking all these blocks that are going to be part of a quickly growing file. You definitely see without VAAI some pretty quick bottlenecks once you start adding 50 or 70 or 100 virtual machines thin provisioned on the same VMFS. That locking starts to add up. So if we can get the hardware to do it, that much better, and maybe now we can get hundreds of thin provisioned virtual machines on that VMFS. So it's just one example, but definitely, absolutely, any integration where we can offload work to the array rather than having the host do it is going to be really, really good. A great example of this is migration. If I have two LUNs on the same array, and I want to move a virtual machine from one LUN to the other, I don't want to do that by reading everything off of the one LUN onto my host and then sending it back down Fiber Channel or iSCSI or whatever I'm using to the other LUN. That's a lot of work. That's a huge amount of stress on my storage fabric, and it's just a bunch of work I don't need to do. I don't want the host to do it, and it's just going to take a long time to do it. Compared to getting the array to do it without transmitting it anywhere, it just makes a lot more sense. So if you're interested, if you want to see what your storage supports and you want to make sure it's detected correctly and everything, this is not really something they show you much in the interface, but if you get in with ESXi, there's definitely a bunch of commands and things you can use to see more details about this. But definitely you need to check with your storage vendor as to what they do support and, what's required to make that actually work. And VAAI is really great. I mean, this is something that's been around for a long time and it works very well and allows us to, bridge the gap a little bit between, something that should be a simple operation and offload it onto our arrays. But really, the biggest reason that VMFS exists is because, typically we would be presented with a generic block device, and VMware needs that set up in particular ways and so on, not in the way Linux would lay out its file system, not the way Windows would lay out its file system, but basically to support the placement of VMDKs onto disks. So we've got quite a few layers here, right? So with virtual volumes, really extending past the idea of VAAI into something called VASA, the vSphere API for storage awareness, what our storage can do is actually provide us with protocol endpoints that the host can communicate with directly without actually having to have this VMFS file system layer in between. So basically getting direct placement of our virtual machines onto a disk group, RAID group, volume, whatever your storage vendor calls it, and getting our storage placed there directly. So you may or may not be able to do this. This does require a little bit of extensions to how the addressing of things like Fiber Channel and iSCSI work. So you have to have the right drivers, and the driver has to support it, and all those things, and you might need to update it, and so on. But can definitely be the next stage of integration really between vSphere and your storage. So sometimes you'll also potentially want to create a VMDK, or you may want to, for example, convert a VMFS 3 volume over to a VMFS 5 volume. Maybe it was never done previously, or maybe you're going from, vSphere 4 up to 6 or something like that, and it's never been put to 5. So you can do that with vmkfstools. You could go in and do the upgrade. I would recommend you not do this. There's potentially some problems with VAAI, and your array may or may not properly recognize what it should or shouldn't do, or it might not be the optimal layout for it, and so on. So it would be better to create a new LUN with a new data store and then migrate things. But it'll also give you the ability to do things that are in the interface, like, creating and extending VMFS and so on, but you can do it from a command line as well. So there's a couple of KB articles and, some details on how to actually use vmkfstools to go in and create a VMDK file directly on the command line if you're interested in doing that. So in the demo, what we're going to do is take a look at some of the fairly generic stuff that we're going to see later on again when we talk about iSCSI, but basically taking a look at storage adapters. We'll talk a little bit about pathing. We'll talk about rescanning and refreshing the adapters. We'll discover, new disks that I've added to my ESXi host, and then we'll go and format those as VMFS. And take a look at some of the options we'll get once it appears as a data store and see some of the things we can do with it. And we'll talk about some of those things more in the multipathing video later on. So I'm connected to my host and I'm in the configuration tab looking at the data stores. So what I've done is this ESXi host is actually a virtual machine running in VMware Workstation. So I've added another, I think it was a 40 gig SCSI disk to this ESXi host. You can see it doesn't show up here as a data store. And actually, even if I go under the devices, it's not going to show up there either. And you can see I've got my local VMware disk, which is actually the original one that I've got both ESXi installed onto, and I also have VMFS on it. And you can see I've also got my CD-ROM here. So, okay, where's my new disk? So if I hit refresh here, you can see it doesn't give me too much. So what I'm going to do instead of clicking refresh is I'm going to click rescan all. And you'll see that it gives me the option to both scan for new storage devices, which is what I want. This is going to be a blank disk that doesn't have VMFS on it. But also, if you do see storage devices, look for VMFS on them. Or at least even devices that you already know about, look for new VMFSs on them. I suppose on a new storage device, if it had VMFS, it would see it. But go rescan for new VMFS volumes as well. If I had a lot of storage here, maybe I wouldn't want to do that. So in this case, I'll just leave both. I'll say, okay, it doesn't hurt. But again, scanning all of my existing storage for VMFS could be fairly long if I've got a lot of it. So now that I've done that, you see it completed down in my recent tasks. If I go over to the devices, now you see I've got a second VMware disk. And if we compare here, you can see that the target is slightly different. So it's on controller 0, but then this is target 1 as opposed to target 0. And then this logical partition number, I think in this case, is 0 as well. So you can see that on there, I've got, a 40 gig virtual disk. It says it's a parallel SCSI disk, and there's nothing really on it in terms of partitions or anything else. If I click onto my other VMware disk, you can see it shows me things like VMware diagnostic partitions and so on, and, legacy boot partitions and things of that sort. Although you notice it doesn't really give me much detail about my actual VMFS here, but we'll see that a little bit later on. So now that I've got the device appearing anyway, I need to actually format it with VMFS. So I'm going to click back over to data stores and I'm going to say add storage. And when I do that, it says, well, do you want to add storage from a disk or LUN? This is not adding a disk or LUN to the system. But in this case, I'm going to say, just yes, it's a disk or LUN. And I've got the one disk that I already have visible to the machine, but that does not have VMFS on it. And it says, well, you know what? Hey, I'm going to do this with a solid state drive. You can configure caching here instead. We're not really going to get into that in this course, but that would definitely be a good idea. But in this case, I'm not going to do it. And it just says this hard drive is blank. We're going to create a partition layout, and I'm going to provide a name for it. And in this case, I could partition it, but there's really no reason to do that. So I'm going to just say to use all the available space, and I've now got one large VMFS5 partition on that disk. Reasonably simple, and if I click onto it, you can see in the data store details, well, I don't have much used on it, but I've got quite a lot free. And you can see that I've got VMFS 5.61 on it with a 1 meg block size, and all my paths are okay. My one path anyway is okay, and none of them are broken or disabled. But that could definitely happen. In this case, it's local storage. It shouldn't really happen, but take a look in the iSCSI videos, and we'll go through this detail a little bit more for actually providing multiple paths to it. And you can see the same thing for my existing VMFS data store. Not really too much that we need to do here. But if I go into the properties, there is a little bit that we can do in terms of things like renaming the data store. You can also increase it. So if my LUN increases in size, then I need to increase the VMFS to go with it. You cannot shrink a VMFS. You can shrink a VMDK, however, and we can also see extents and so on here. If we go to increase it and we add an additional disk to it, then we would have what are called extents. So when I go to increase it, if I have multiple disks available, it will show all the disks available. One of them will potentially say that it's an expandable reservation. So that expandable means it's a disk that already has that VMFS on it, and then we can extend it onto it. If I pick some other disk, or if I do that accidentally, I might get my VMFS across multiple different LUNs, which is potentially cause for concern. And as well, we were talking about the vSphere API for array acceleration. If VAAI was supported, we would see that listed here in the hardware acceleration column as well. And this is basically really the same dialogue that I got when I did add storage before. So I'm showing it to you afterwards, but we could have done the same things there as well to verify that we're picking the right LUN to put the right data store onto. So there's not really too much else beyond that. For a local data store, yes, I can, right click on it and I can rename it and so on. And you can see I can also unmount it or delete it. So if I go to unmount it, then I can pretty easily mount it again just by going through that add storage. If I delete it, that is going to delete the VMFS that's on that LUN. So that's quite different, of course, and we don't want to be doing that. So generally, we don't want to be doing that. Maybe you do want to do it in a particular case. That's great. Make sure you know when you need to do it and then do it as appropriate. So in summary, the VMFS file system is a very, very good file system for what it's designed to do, which is store virtual machines and, the related files like templates or snapshots and so on. But it really isn't doing anything that the array couldn't do itself in terms of placing things on disks. So things like VAAI and VASA allow us to offload more and more work to the array. But then suddenly we need to be more integrated, or our management needs to be more integrated with the storage and not just with vSphere. So that is a bit of a problem, but a lot of the storage vendors provide plugins and such for the VMware tools so that you can manage their storage from inside the vSphere interface. So that could work out pretty well, and check if those are available for you. And in the next video, we'll take a look at setting up the network file system, which gets us access to a data store, although doesn't actually use VMFS, but we will come back to VMFS when we talk about iSCSI and multipathing later on.